and today we'll be going through RShiny. So it is an interactive data visualization tool that is common among data scientists, and we'll be using a case study of ABP, that is American Board of Pediatrics, Certifying Exam Prediction Tool that I built for them. Once again, my name is Hope Adegoke, and I am a PhD student in the University of North Carolina, Greensboro, and also a graduate research assistant at ABP. All right. So now in today's meeting, what we'll be learning is data visualization, understanding the structure of a Shiny app, then the ABP certification prediction tool overview, and also final tips for when you want to build your own Shiny tool. All right, so we'll be moving a little bit fast because we don't have a lot of time, but please, you can feel free to ask questions along the way, maybe in the chat box, and we'll get to it. All right. So first and foremost, we have the data science. Apologies. The data science. How do I move this? Okay. The data science process, right? Which a lot of us are familiar with. You import your data, you wrangle, you explore, you transform, you visualize, you model, and you communicate, right? So there's this niche of it that is between visualization and communication that we normally term as interactive data visualization. So it's a measure where you can visualize and communicate your findings or your data analysis using an interactive data visualization tool. Now, we have a couple of these tools in which Shiny is one of them. But why do we even do data visualization? Did someone say something? Matthew. All right. All right. So, number one, data visualization is more engaging and adds better user experience. It empowers the user. It helps in storytelling, easy to understand and remember, and also straight to the point when you are communicating with data. So you can see here we have a couple of data visualization tools that you could explore. Now, why are we using RShiny? RShiny is a web application framework for R, and it helps turn your data analysis into an interactive web application. And why we use it is because it is open source, I mean, mostly free, and you can develop it with the same language that you use for your data analysis. So if you are conversant with R, you will definitely be able to use RShiny. And you don't really need HTML, CSS, or JavaScript knowledge, but you can include it if you wish to. Now, there are already pre-built widgets that you can use for building your application with little effort. The codes are already there. You just need to, pick it up and drop it on your app, then modify for yourself. So we have a couple of examples with their codes. So there are a lot of examples on the Posit app. So you would see a lot of feature demos. So you can scroll through, go through the Shiny apps, you see the codes, and you can lift them and modify them for your own use. So this is a very good place to, hit the ground running. Now, how do you build a Shiny app? Now, we'll go into the technical bit a little bit, and it will be beneficial if you have an understanding of R. Now, the first thing you need to know is the full compartment of a Shiny app. It basically has a UI and a server, right? So it has the UI components and the server components. It can either be put in separate scripts or combined together in one script. So we have the fluid pager that we use for the UI. It lets your display adjust automatically to the browser dimension. So whether you're checking on your phone or you're checking on a laptop, it would adjust the view. Now we also have the server function, which contains all the code that you need to run the app. So the inputs are input, output, then optionally session, right? So This user interface, what is it and what does it consist of? First of all, you need to load your library, which is the Shiny library. If you don't have it, you need to install it using this code over here, or just install from your RStudio IDE. Now, all right. So how is the UI structured? It is a series of nested Shiny functions fun which controls the layout of the content, right? So we have the fluid page, then we have the title panel inside the fluid page, then also the sidebar layout inside the fluid page. Now, this sidebar layout has the sidebar panel and main panel. So we'll still explain all of this in more details. Then we have the server function over here. So, I mean, anyone can come first, but that is basically the structure. Then you use this to launch the app. So running this, you would get this on your app. So you can see the title panel. We named it title panel. So you can see the heading over here. Then we have the main panel, which we named main panel, sidebar panel, sidebar panel. And we said it should be by the right. So you can see the sidebar panel by the right and also the main panel. Yeah. So this is just letting you know how you can move things around. All right. So there are a couple of functions that you can use in R, and they are all in this link, shiny.posi.co. You can get a list of them. There are numerous that you can use for your Shiny app. You can also format text, like your basic HTML. You can use the H1, H2, H3, which are first level header, second level header, and all of that. So you can modify your app to change color, the style, the size, and whatever modifications you want to do, you can get it done on Shiny. You can also add images. So now adding images, you can add it in a place like this. So I'm putting it in the main panel, and the IMG is a function where you impute a link or the path to your image and also specify some dimensions. So now you have to make sure that this image, I named it h.png. This is my logo. So I put it in a folder called www. So you need to ensure that is done. So that folder needs to be in your directory that your app itself is, where your UI, your server codes are. You need to put that www folder there. Then you put your images or whatnot inside that folder. Then you can call it from the RStudio, then it shows up in your application. You can also add widgets. So what are widgets? Widgets are interactive web elements. So you can see selecting single choice, multiple choice, sliders, submit buttons. So there are a lot of widgets. You can also go through this link here to view those widgets. And the codes that are associated with them are also on the website. So you can just copy the codes and modify it for your own use. So the structure of a widget, basically, it has a name that you use for calling it. Then it has a label that is used when you are displaying it on your application. We would also get to that in a moment. So now look at this. We are adding widgets. This is our title panel. We have our fluid rows. So these are like spaces, these three, column 3. They are spaces that you can put. You can put 4, 2. It makes it, narrower or wider. Then this widget text input, this is it. So you have text area input. I named it text, and I want the label to be text input. That is what is showing here. And the value to be ERM Shiny app. So this is the default value. So you can edit this. Then there's a checkbox, which you can check. There's a date input, So you can see these structures that you can add to your Shiny apps. Now, moving forward, we have reactive output. So when you impute in your widgets, you need something that would return something to you. So that is where the output functions come in. So widgets allow users to input their choices, and reactive output is a response to those choices. So when you are programming it into an app, it takes 2 steps. You will add an R object to the user interface to indicate where it should be displayed, then add instruction on how to build the object in the server. So you need to indicate it in the UI where it should be displayed, then instruct it on what to do from the server function. We'll also get into that. Now, look at this example. We added a sidebar layout just for a number to be chosen, right? So this is a slider which you can move around. So once you move this around, it is just an input. You are just telling the app that, okay, I'm moving this to 51, but what does it do, right? So that is where output comes in. So I want it to return a text output named text. I didn't define anything. I just defined the location, right, and the name. So after doing this, I now go to my server function and say, okay, output, then $text. So use this dollar to call attributes of functions. So when I say $text, it looks at this, okay, there's a text here. What do you want me to do? I say render text, right? So when I say render text, what do you want me to render? What text do you want me to render? And also, okay, paste, you have selected, then my inputs. So remember we said this, we have inputs and outputs. So this is the input which we define, slider input. There are a lot of inputs, but this is a slider input. And the input, we are saving it as none, which is the name I gave to the input. So when I call that input, I want you to return this number that I'm imputing. So whenever I change this to maybe 40, this will change to you have selected 40. So this is basically, a reaction to an action. That's why we call it a reactive output. So we have a couple of render functions that you can use. In the previous example, we used a render text. You can see it here, render text, but there are a couple of them that you can use. You can put plots, you can put tables, and a lot of things. So basically, that is how reactive outputs work. Now, server. What is in the server and what happens in the server? So the server contains all the codes you need for executing the app and how frequently the code is being run, right? So you can define things around maybe I want to define the function for a 3PL model or a 2PL or whatever. I can define that outside the server function, right? But I can now use that in the server function. So the things I put here under the function, we only run once for each session. But for the render, when I put anything inside the render, it runs anytime the input changes. So we'll still understand that dynamics later on. So now, other Shiny functions that you can integrate, there are reactive expressions, absolute positioning, interactive visualizations, progress bars, integration with R Markdown, Shiny Server Pro. So there are a lot of things you can do with RShiny, but you just need to start small, build it up. Whatever you feel you need, you can go to those documentations to check how to get it done. So you can include maps, and a lot of things in your Shiny app. So now we'll be going into R itself to look at one very simple Shiny app to buttress our point. So let's go to R. Now we have this app here. So I added my Shiny function over here. Then I defined my user interface. Now this user interface, it has the fluid page which makes the page responsive to devices. I add my title that will be on the top of the page. I have my sidebar layout, which contains my sidebar panel and my main panel. So this sidebar layout split the page into sidebar and main panel. So inside the sidebar, I added a couple of slider inputs. So these are widgets. So this widget is for choosing my sample size. This widget is for choosing my main. this is for choosing my standard deviation, this is for choosing my bins, right? And I have also defined this. I want the minimum value to be this, the maximum to be this, the default value to be this, and in what steps, right? So let me just run this so you could see it side by side. All right. So you can see all the slider inputs here, which are these. You can see their names and the labels. So it is the labels that show up in the app, right? Then we have the minimum, maximum. You can see for sample size, the minimum is 10, maximum is 5,000. The default value is 500, and it goes in tens, right? So that's basically how these widgets work. Then main panel, I want it to display a plot. So I use a plot output. There are different types of output functions you can use. But since I want a plot, I define a plot output. And I define, the dimension. So this is just a name for this histogram plot, right? Now, going into the server, I want to define what will happen in this place. So you can see it creates a space to display the plot output. So there's a space there, but there's nothing there yet. So now I tell it that, okay, I want a server function. The input would be the values it is getting from the UI. The output is what I will be giving out, right? So now I'll define my data because I want to create a histogram. So I need data for that histogram. So the data should come from what the user inputted. So it's speaking, you can see now I'm using the names I define. Input $n, that is this. Input min, that is this. So that is what I'm calling. Now I'm using this data to now plot the histogram. So you'd see my render plot here. So it is trying to tell me or let the app know that, okay, I want something to be plotted in that space of east plot, which was defined here. Now we have our histogram. You can input, your normal attributes, breaks, columns, the title of the histogram, xlab, whatever you want to define here. So once that is done, you just launch your server and you run this code, and this would be Hope. So to run your app, in case you guys didn't see, you come here. So once you have all your codes in there, you run it here, right? And your app is good to go, and you can, move things around. So as I'm changing the input, it is updating in the server function that, okay, this is this, and I'm updating, right? So you can also open it in the browser to see it in the browser. And the fluid page that we talked about, that it adapts to screens. So you can see that as I'm changing my screen size, it is adapting to it, right? So that is what this fluid page is useful for. All right, let's go back to the slides. All right. So we have a couple of resources that you can make use of. I've mentioned the shiny.posi.co repository. You can get a lot of information there. Then there's this textbook, RShiny textbook, that you can read to get a hang of what is going on. There's also AI that you can use to make your work faster, cleaner, and efficient. Make sure you use AI. I'm a big advocate of AI. It gives you an edge, and you get to do things that you wouldn't normally do in a short period of time. Something that will take you 3 months can take you 1 week because you are skipping a lot of unnecessary steps, right? But make sure you understand the syntax, what it is doing, how it works. And that is what I'm showing you here today. All right. So moving on, we'll be looking at the ABP Certifying Exam Prediction Tool that I built. So that is the case study for today. So you can go into this link and see the app for yourself, but we'll also still go into that. So backstory on the data we used. So IT is in training examination. So those are retired certifying exam questions that ensure they match the content specification. And IT has a moderate correlation with the scores on the certifying examination. And so ITs are a couple of exams that is being done in medical boards. So it can be year one, year two, year three. Sometimes there's a year four. Then you do your certifying examination, right? So training programs use these IT exams to see trainings that need support or remediations. And the IT is a valid feedback tool to indicate overall preparedness for the certifying examination. Now, so that's the backstory of the data that was used. Now, what model did we use for this? We used a probabilistic graphical model, which is called Bayesian network. So you are able to represent different variables and their conditional dependencies through a directed acyclic graph, which is this. So you define those conditional probabilities, right? And the model learns structure from this. So you can try different structure and see if the accuracy of the model increases, and you can go with the best model or model as it is um, known to be in that domain, right? So there are some models that might give you good accuracy but doesn't make sense. So you need to also take note of that. You need to know what variable is the parent and what variable is the child. And so for Bayesian network, there are no strict distributional assumptions. It uses conditional probability distribution. It's very flexible. It's useful for small data, and it provides accurate score forecasts. And that is what we used for modeling the predictor tool. Now, this is the DAG model we used. So we have the year one exam, which is the parent to year two and cert. Year two is a parent to three and cert, and year three is a parent to cert. So we use this structure for the general pediatrics model, and we use this structure for the medicine pediatrics model because they have 4 years and general pediatrics has 3 years. Now, how was the app built? First, we clean the data. We had a script for cleaning the data because most times in the field the data won't come how you want it to be. So you need to clean, move variables around, transform, and all of that. So after we clean the data, we fitted the model in another script. So we have two different scripts. So one for fitting the general pediatrics and the other for fitting the medicine pediatrics. So after fitting the model, we saved it in an RDS file. So an RDS file is a kind of R file that saves, models, lists, whatever, so that you can call and use later on, right? So we fitted the model and saved the um, outputs into the RDS file. So now we moved or we called the RDS file in our Shiny server. So now we are here in the Shiny app, right? So in the server, we called those two RDS files. So we had two models. So if you check the link, you would see two radio buttons. So one is for the first model, right? The second is for this. Then we have the Shiny UI, which designed everything in the app, the plot cards, the branding, the color, the logo, everything was done from Shiny. Then the instruction tab. So those are a bunch of texts that was done from Shiny too. So let's go into the app and see what we are actually talking about. Let me exit this. Hmm. So this is the application. Let's wait for it to. All right. So this is the American Board of Pediatrics website, and this is the Shiny tool. So what we did is we embedded the Shiny tool into the website. So this is the website and this is the Shiny tool. So we have two tabs. We have the prediction tool and the instructions. So there's a function for that too. Then we have a couple of rows that we defined. We have rows for the score input. So you can see I can input 100 here, and we have plot cards that contain histograms, right? So we built histograms for this. So each of these are using the same function to generate the histogram. But this is a little bit different because it had color coding for people that scored above 180 and people that scored below 180. Then we have this prediction tab too. So all of this is very interactive. So the Bayesian model is able to, fit the conditional probability if you don't know your year two or year three, right? Based on the distribution of your data. So if you now know your year two, let's say you get a 200, it now refits, right? And the prediction changes. So a lot of things are happening under the hood. There is bootstrapping happening from the RDS file we imported. So anytime I change a number, a lot is happening in the background to recalculate um, your predicted score or your predicted distribution. So it has the model already in it. So it's just waiting for your user input. And once you input that, it does a bootstrap and returns all of this. It calculates the confidence interval, the pass probability, and all of that. And a couple of things were done at the back end to ensure that maybe if I'm typing 105, it doesn't render 10 first before 5. So I made it wait a little bit for like a second for me to finish typing before it starts calculating. So all of those things can be done from RShiny. Then we have the instruction, which is majorly just text. So, I showed you some text formatting functions, the H1, H2, all of that. You can define them and make it make sense in a beautiful, shiny app like this. So basically, this is what was done for this application, and that is how it works um, at the back end. So um, let's just finish the slides. Okay, so we are good with this. We know how our ABP app now works. So now take away from this presentation. Number one, you need to build a minimal working app before adding complexities. The app I just showed you was months of work, right? So we started small, then we added things to it, right? So it's not that it came out of nowhere. It was being built step by step. So we were moving things around, changing things, testing things until we got the final dish. So when you're building your app, you might not need to build something as complex as that. Just, work minimally and build and grow from there. So also use reactive expressions wisely. Don't do redundant computations because it takes memory. Like I told you, a bootstrapping is happening at back end of my app. So you need to make sure that things are not just running for fun because you need all the computational space that you can get so that you can have speed, right? So and it won't drag you. Then if you are building a large app, break it into modules. So some Shiny apps have R markdowns, you're adding logos, you're adding pictures, you have a lot of things like it's being built modularly. You have your server script, you have your UI script, you have a couple of things that is going on. So you need to break it up and make sure that everything is clean and separate. Then leverage packages. So there are a lot of packages you can use with your Shiny app. You can use your normal packages and also some additional Shiny themes and a lot of them that are available for you to use. You can check that Shiny deposit and you'll see a couple of things. Then modify existing apps from Puzzle Gallery that fits your use. You don't have to reinvent the wheel. Make use of what you have. You can go through their gallery and, okay, you see that this app looks like what I want to achieve. Then you get the codes, modify it, use your own data, then deploy. You've created your Shiny app, and it's as easy as that. You don't need to start from scratch all the time. So I've added this slide and the histogram we built into this GitHub repository. You can look at it from there, download it, play with it. Then you can get the slides also from there. Download it to access all of these links that I've added here. That will be the end of this presentation, and I'll be leaving time for questions. Thank you very much. My name is Hope Adegoke. I'm a PhD student in UNCG. You can contact me in my school email or work email, or go through my website. There's also a QR code here for you to, give me feedback on this presentation. If you feel it was good, give me that feedback. And thank you all for listening, and I'm available for any questions.
Thanks, Hope. That was excellent.
Thank you. Am I on time?
Yes, you are.
All right.
I do have a couple of questions, and please feel free to ask questions. You can raise your hand, you can put it in the chat, or you can unmute yourself. So going to start with, I have 3 questions for you, my guy. The first is, how do we make the Shiny app built public? I see you just talk about how to run it from the Shiny. So the first question is, how do we make it public? This follow-up question on that is, I see that your company website uses abp.org, then certifications and all of that. Do we have to pay for a domain name to host it under? How does that work? And it looks like this is the third question would be, this looks like a software developer skills. What can we not do with Shiny app that's different from a software development? And do we necessarily need this skill as a psychometrician? Please. Those are my 3 questions or 4 questions.
That's more than 3 questions. But yes, I would answer all of them. So if I forget anyone, please call my attention to it. So the first question you had, I'm very sorry. I had a slide on that, but I don't know where it went to. So once you build your app, you need to publish, you need to deploy it, right? So this is how to go about it. We have our area. Let's say we want to publish this. When we loaded our app, it was running uh, in the local server on my computer. It's not out there. So if you want to publish, you just need to come here and see publish application, right? So when you click on publish, you would see all the files in that directory. So if you add some images, your www folder that has images, you have different scripts for server and UI. You need to check all of them. Then you need to add an account. So this is my POSIT account in shinyapps.io. I'll check for that slide and include it so you would have access to it. So you would see where you can log in, add a new account. There are easy steps for you to go through. I think you need to go get a token. So once you open your account in shinyapps.io, you would have your account page, and you also see something like token. So it's like an API key of some sort. So when you copy that token, this R will ask you for it when you're adding a new account. Let's try and do something like that. So you can see choose token. So you need to get that token from your account. You copy it and paste it here. Then you'll be able to connect your account. So once you connect, give it a title, then publish. So you'll see that app in your account online. Then you can share that link with others. Now, the ABP link that you saw is actually our ABP website. We are not using a custom domain because the Shiny app is embedded in our website. So we used an iframe. So an iframe is like an embedding HTML kind of code that puts your link inside a website, right? So we are embedding the Shiny app into our website. So it's not given out in a separate standalone um, Shiny app, right? So that's why we didn't use a custom domain. But you can also use a custom domain. That means having something like hopeadegoke.com taking you to your Shiny app. But now you will need to pay for that. So there are a couple of payment structures that you need to do for that. But that is if you want it to have that kind of display. But if you are not really interested to show like this DIO something dot shiny something something something, that will be the link, right? But if you want to personalize it, you need to pay so that you can use your custom domain. That's the second question. What's the next question? Yeah, unmute.
The next question is, what can we not do with Shiny app, and how is that related to software development?
So I would say software development is another niche on its own, right? Because Shiny apps is majorly for displaying your analytics. You did some sort of data analysis, you want to display some sort of data, you want to make it interactive. That is the space for Shiny apps. Software development is another thing on its own. But Shiny has a lot of attributes that can mimic software development to an extent that you might not need software development. But they are also, intertwined. Software has its own, intricacies that you won't be able to do in RShiny. But basically, as data scientists, as psychometricians, and we want to make interactive dashboards, as you can see from this, it's something that is on its own, and you have your instructions, you have your prediction, you can impute, you can even, link it to a database. So it's almost like you're building, I mean, you're building an app basically. So they are very related, but software development, don't let us put them out of their jobs. Let's leave them where they are and they can continue what they do. But this is for us. Now, you mentioned that is it a compulsory skill? I don't think it is. I don't think it is for a psychometrician, but it is essential if you want to add something to your belt, an extra tool that, okay, yes, I can build Shiny apps. I feel it is important, but it is not like a necessity for you to have. I mean, there are people that do it. Maybe you have an idea, you can give it to people like me or Henry or something that, okay, help me build this. I have the idea, help me do it. But that doesn't make the other person not a psychometrician. Right? But it's a very good tool to have in your belt. And if you are familiar with R, it is very easy to do. And Dr. Kim teaches an R class where you would learn all of this very well.
Yeah,
Related to
thank you.
that, just curious, does the when you mention the computational load, especially if you're doing really complex things, does that happen server side or client side? Like if I were to ask your ABP app to do something really complicated, would it slow down the ABP server or would it just slow down my computer?
So it will slow down your computer, not mine,
Okay.
because it
Okay.
is, once it's deployed, it's as an instance for you, right?
Yeah.
So whenever you are doing something that's computationally intensive, it will slow down yours. So except maybe modifying something from the script, or maybe publishing midway, that's where it can affect a lot of people, right? For the free version, there's a limit to how complicated your app can be, right? So most times you won't even get to that limit.
Interesting.
So I have two questions for you. So first is how to what degree now that these softwares are available, the tools are available, that everything that is being built and pushed out all right in the world and people have access to them, to what degree are there standards, in other words, are there standards for reviewing or making sure that the apps being shared are reliable, trustworthy, right?
Is it trustworthy in terms of security?
Trustworthy in terms of their accuracy, in terms of their utility. In other words, if you are running them on data, and the question is, are there standards out there? Because it seems to me like right now it's a bit like everybody who can build it are building, but then the question is to what degree are they being like also kind of certified? See what I'm saying? All right.
Yeah.
Because I know, like, for example, if you were to do this type of thing, let's say using SaaS or all these proprietary software, there will be some kind of quality control, right? Before they get put out and people can use them. So this is probably one of my main concern, right? Because now I can tell that sometimes you have people who are very good programmers, very good at software, but may not really understand the implications of when things are not being generated or produced as what we would expect. You know what I mean?
Yeah.
Right? So I don't know. I mean, you may not have the answer for that, but this is one of the concern, I think, right? Because it's a bit like, building surveys. Like I was saying, it's like, because you have Qualtrics or you have all these tools out there, anybody can build a survey, right? The question is how reliable, to what degree can you rely on that to say, yes, I'm using this tool and the data or the output I'm getting is something I can count on. So I think this is one of the things probably maybe we should be thinking of, or at least if there are high stakes decisions being made, right? When these tools are being used, the question is, to what degree can we rely on them?
Yeah.
All right. Thank you, Dr. Dev Sunase. So what I can say on that is I'm not aware of any standards available, right? Because R is open source. Anybody have access to it. Anybody can do anything with it, right? So the quality check that I would say is working here is based on the builder. So the builder will let you know that this is what I did. This is how I did it. If you want to validate, so some builders put their codes on GitHub where people can check and raise issues and, let them know that, okay, this is not right. It's just like, let's say I build an IRT app and I say 3PL model is this, and the formula is not correct. The app will still work, but the formula is not correct. And who will tell you that? So it's when you maybe check it against something else and say that, okay, this is consistent. There's an RShiny app we use for, I think, CTT, and I'm sure that has been validated, right, with maybe other applications, and they saw that the results are equal and it is correct, and that is why we were told to continue using it. So it's a builder part of the job, right? So in this app, we added instructions. We told them the method. So this is for medical people. That's why we didn't put a lot of technical details. But we are also writing a documentation for this application. So it will be somewhere. The technical details will be somewhere so that if anyone has queries or whatever, we can, give them the details of, okay, this is how the pass probability is being calculated. This is how the confidence interval is being calculated. This is how the graph is being generated. So it's a responsibility of the person that built the application.
One more question I have for you. I don't know anybody on the in this group can chime in, but the thing is, you probably know that Python is very popular in basically anywhere, everywhere, right?
Yeah.
And R is only, I would say, is popular among people who knows about it, but it's not like as widespread, I think. Okay.
Yeah.
So where do you see building apps like this, all right, or in the R environment, uh, going in the future? I know it's a specialized type of app, but where do you see that, in terms of a lot of the work that was used to be done in R are being done in Python now, right? And is there like is there a possibility over time that Python will displace R as the Go tool?
All right. Thank you for your question. So the R and Python conversation has been always there, right? But
Yeah.
R is still standing strong. So Shiny is both available for Python. It's available for R. There's a Shiny for Python. There's a Shiny for R, right? So your question is that is there a scenario where Python will displace R? I don't think so. R will continue to be relevant as long as the community keeps building it up. So, like I mentioned at the beginning of the presentation, R has a very big community that keeps bringing innovations and all of that. There are RShiny apps that integrate AI and all of that. So majorly, Python has its own niche, R has its own. So I don't think R is going anywhere. R will continue to stay relevant.
Yeah, I do know that Python is faster computationally in a lot of ways than R is. So Python is probably better as a standalone development language than R is. But I don't think Python can compete with R as far as the depth and sophistication of the statistical analyses that are possible through it. And the way Python would compete is by having people code R functionality into Python. I feel like a lot of it is being developed initially in R. Maybe I'm wrong about that, but I agree with Hope. I think there's a pretty robust and active R community. But like anything on the internet, it's caveat emptor. You have to only trust stuff that comes from a reputable source like the American Board of Pediatrics, not just some random guy's website where he talks about his favorite bands and gives you his Shiny app.
Just to also add to what Hope said, I think is it last year or 2 years ago, the our community was combined. They renamed them to POSIT. And positron is a combination of Python and R. So it's not just, so now whatever you can do with Python, you can do with R. So they are linking both together. That's why they call it positron. So it's a combination of R and Python. That's why now when you are coding in R, you are able to also code in Python. And or now that we even have AI, if you have R code, you can simply just convert it to Python code with just a prompt. So I see that both are actually used simultaneously, and there's no one displacing another. It's only that for AI data science related projects, Python has a larger community. But when it comes to analytics, statistics, psychometrics, R has a larger community. So I don't see anyone displacing anyone, but just two ways to do different things.
Yeah. Any other questions? And just a little takeaway before we go, if you haven't connected your R to GitHub Copilot, please don't sleep on it. I can tell my how to create a Shiny app for a 3PL model, and I would start coding for me. You can see it's already suggesting my libraries. Can you see? So let's create something, new file, Shiny, IRT. I don't know why I'm just moving to IRT as my examples. So create a 3PL probability plot, IRT models. So it starts giving you the codes, right? And with this, you can instruct R on things you want to do, and it will start writing the code for you. This is AI just typing. We could verify the app, run application. So I just built a Shiny app just now in front of you using AI, and would have it running. So you have your probability curve, you have your ICC, you have ABC, you can adjust, and you have all of that. So to do that, you just go to Tools, Global Options, Copilot, log into your GitHub so you can sign in. And once you sign in, that's it, and press OK. So if you have tasks that you have in your head that I want to do this, but I don't even know the code to do it, just write it in a comment and AI would get to work. So that is another snippet of love I'm showing you all. All right, any other questions?
Thank you so much, Hope. Any other question, please, you can still reach out to Hope.